Good morning, guys. In today's mini lecture, I would like to go through and talk about the arrangement of the periodic table based upon our four orbitals, the s, the p, the d, and the f orbitals. So before I do that, I need to give you just a quick little review on the different orbitals. So first of all, when we're talking about the s orbital, and I'm going to use a little cursive s, is going to have two electrons. So if I draw the actual orbital, it looks like this. So I can have one electron that goes here, remember that clockwise spin, and one that goes here with a counterclockwise spin. So I have two electrons. Now if I have the p orbital, that's going to have 6 electrons, and if I look at its individual, and we call them rooms, I end up with 3 rooms. We know that each one of them can hold 2, so it'll be 1, 2, 3, 4, 5, 6. So that's what the p orbital looks like. The d orbital has 10 electrons, and it's going to have a total of 5 boxes. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So they all go in one at a time, one per box, before they start doubling up. The last one is the f orbital, and it has a total of 14. So I'm going to go through and put 7 rooms. All right, so I'm going to leave it like that. I'm not going to fill all of those in, and I'm going to go back, shrink my camera size down just a little bit so that we can now see my screen. So everyone now should be able to see my screen, which shows you the s, the p, the d, the f orbitals on the periodic table. So when I look at this, it's really, really cool. We know that the s orbital has 2 electrons. Well, the first 2 families, the Roman numeral 1a, 2a, which is your alkali metals, your alkali earth metals, represent those s families. So you have the s1s and then the s2s. Now I'm going to move all the way over to the red block, and if I look right here, this whole section of the periodic table, starting with boron, going over to neon, are going to be the p orbitals. Now we said that the p block, or the p orbital, holds 6 electrons. That's going to be 1, 2, 3, 4, 5, 6. I love it. And then our d block, in here, these are our transition metals, and we know that it has 10. And sure enough, if I start right here with the scandium and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to end with my zinc, and that zinc is going to be a D10. So that D block represents all of these, and those are our transitions. Finally, if I went back down here to the very, very bottom and I did the F, there's 14. Yeah, if I started counting and I went all the way across, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and finally 14. So each one of the areas on the periodic table, the S block, the P block, the D block, and the F block. Now earlier when we first started the periodic table, I used the X and the Y axis, and I said period 4 in family alkali metals. So if it's an alkali metal and it's in period 4, then I'm going to go 1, 2, 3, 4. The first one is an alkali metal, so that would be potassium. Now what I'd like to do is I would like to go back in and show you how we're going to use the same general concept whenever we start looking at the electron configuration. So we've already figured out how to write out the electron configuration. So I'm going to look at the electron configuration of the potassium. I get 4s1. So guys, we have 3 things that we need to know. Okay, so first of all, instead of it just being an X and a Y, this is like a location on the periodic table. If I look at it, I'm going to come over here. The 4 represents the period. 1, 2, 3, 4. The S represents where it's located at. And we know that it's located right here at the S block, which is the first 2, alkali, alkali, earth. And then we come over 1. So I come over 1, and sure enough, that is going to be potassium. Let me give you another one. I want to do 2P3. Now, I always get students who go, is that P cubed? Is that S cubed? And when we're doing these, remember, this is not math. This is nothing more than 3 different symbols that we use. The number, in this case is 2, tells us the period. The P, this case, the P block tells us the location. And then the 3 tells us the exact location. So if I go through and I go down to the second period, 1, 2, I go over to the P block, that's the red, and then I count over 3. 1, 2, 3. I'm at this element right there. Now, on the periodic table on my screen, it doesn't have all the element symbols, but I can do the same thing up here. I can go to the third one. This is my second period, P block, 1, 2, 3, and 2P3 represents nitrogen. So I hope that this kind of helped you as far as going through and being able to use what we've been learning how to do. Our orbitals, the S, the P, the D, and the F, and being able to use that to do a new way of locating the elements. All right, thank you very much, and I'll talk to you a little later.